Hello and welcome to today's webinar with Styrenics Circular Solutions entitled Full Circularity Inspired by Design, Powered by Styrenics. I'm Victoria Hattersley, Senior Writer at Packaging Europe, and I'm pleased to see there are so many people here today. Now, following on from our previous session in June, which discussed, among other things, the implications of a recent successful life cycle analysis for recycled polystyrene, today will be focused on how circularity can and will be designed into the Styrenics value chain. So your host for today is Reci Schoenfelder, who is Chair of Advocacy and Communications at SCS. So now I will hand over to Reci. Welcome, and I look forward to hearing what all the speakers have to say today.
Thank you, Vicky, for your kind introduction and a warm welcome to all of you. I'm Reci Schoenfelder from SCS, and I'm happy to be your moderator for today. We are delighted, as Vicky said, that so many of you are joining us this morning. We just had over 760 registrations, so very glad to see the big interest in circular styrenics, and of course the topic of the impact of design for recycling on the unique circular value of polystyrene. Now, what is today about? In our past events, you have heard about the easy sortability, the excellent recyclability to food contact standards of polystyrene via the various recycling technologies that we offer, the drop-in solution of recycled polystyrene in existing converter equipment and form, fill and seal, and the favorable environmental footprint confirmed just by a recent LCA study. And now the value chain is taking it to the next level. We are now focusing on design for recycling, and we aim to maximize the feedstock that is going to our recycling technologies, and with that accelerate the transition to a circular economy. And for that, I am delighted to be joined here by this great panel that you see on the screens. Let me introduce to you Jens Kartmann and Herman van Roost, both from SCS, Frank Eisenträger from Ineos Styrolution, Jivan Jiajiadan from CHEDUP, and Gauthier Massib from Citeo. Thank you for joining us. Before we get started, a couple of housekeeping remarks. We will hear from each of the speakers in turn, and later on we will have a panel discussion and a Q&A session. We have already received a couple of advanced questions from our audience, but it is not too late. We welcome your questions. So I'd like to encourage you to use the right-hand side of your screen. There you see a panel where you can type in your question. And with that, and without any further ado, let's get started. And I would like to welcome Jens Kartmann, Secretary General of SCS. Jens, could you give us an overview of where we are with our circular mission and how design for recycling comes into play? Take it away, Jens.
Yeah, thanks a lot, Reci, for your kind introduction. And also from my side, a very warm welcome to our second value chain event in 2021. And I'm very pleased and also delighted to kick off today's event and having the honor. The unique circular value of polystyrene propelled by design for recycling. This is a very strong message finally to our, and firstly and finally to our PS value chain, but moreover and very concretely also outreaching retailers and brand owners. And not only that, we also reach out with this message to our key stakeholders outside SCS, outside our value chain, including the EU policymakers. The fact that we together with our value chain are now raising the tremendous potential of circular design into a variety of second life applications roots back to three cornerstones of polystyrene recyclability. So allow me to recap to our June event and those three cornerstones when we concluded all together with our value chain that now with those 3 cornerstones and the comprehensive life cycle assessment we did in this event and open this also to the value chain, we concluded polystyrene now has it all. So what does it mean if we say polystyrene has it all? Starting with the first cornerstone, the feedstock. We have a critical mass of more than 800,000 tons, which is packaging, which is overwhelmingly food packaging, and also one can say widespread mono solutions are already in place, not too complex solutions. So this is giving high potential for closed loop recycling. And also with the polystyrene intrinsic outstanding sorting advantages we had heard about and also learned today again, at highest 99.9% of accuracy and quality. We have really a little risk, a high accuracy, high quality, consistency, but also a little risk of any kind of misuse or mismeasurement and all that. The second cornerstone are our technologies. If we look at the broad range of our recycling technologies, and here you see 3, but in their development it's even broader in a way, we have 3 core technologies accelerating the recyclability of our polystyrene materials. And this basically is quite unique, as you know, and also with this multiple technologies, and today we talk mostly on the high purity mechanical recycling. Again, we have a strong asset and can initiate multiple second life for our material polystyrene, and this will be also content of today's presentations by my fellow moderators here, which accompany me later. On the output, I think striking message here from the converters, we have a drop-in solution. The recycled polystyrene shows same behavior, property, mechanically, physically as the virgin polystyrene. This is great news for all kind of application. And the last point here I'd like to drag your attention is rather important. We now more and more come into this freedom of design, of circular design, and all kind of recycled contents levels are possible to pursue those applications. And all those 3 recyclability features I just mentioned have proven very favorable environmental footprint. Remember our LCA event in June and look at our website. And also we are fully scaling up our activities, our circularity in line with the EU recyclability targets and the strategy in 2025. So as we talk about today's event content on circular design, the moderators which are coming will be able, and on the next slide we have a short glimpse on that, will be able to show and explain this much better than I can do, but I still give you a glimpse here on what you can expect today and why we say circular design is propelling the uniqueness and circular uniqueness of polystyrene. As we talk about it, we firstly look at the circularity matrix. This is a great demonstration of our ambition, basically from the waste even to the end user and in between all the application and the cross-use and cross-fertilization of all our polystyrene applications. And this is not only closed loop, which we are very much focusing on, remember the packaging stronghold we are having, but also allowing cross-moving about industries applications to even open loop, and Herman van Roost also will explain how it's going to be. But this is really another strong uniqueness of polystyrene, that we are not depending on one industry in a way. We are focusing, but also we have multiple choices all over the place from waste to end user applications. To demonstrate this and give guidance, we have now already scaled pretty nicely with Reci Class. Reci Class, I think, is known. However, Frank will later on explain where we are and what we do on Reci Class, because this is giving us the guidance, the confidence, the consistency, the quality guidance we need in order, as I said earlier, if you reach out now also very much to brand owners and retailers, giving this confidence of full compatibility of our materials to circularity and all those requirements we have to fulfill. And last, but by far not least, you will learn from Jivan. I mentioned the drop-in solution, but it's going further now from Jivan and Gauthier. You will learn about the Monomaterial yogurt pot. Another great example how far we can go already with our materials. it's really the optimum, the maximum, but this also includes, it's not a dream, it's not a wish, it's real. You will learn about that, and it demonstrates nicely our first steps also to circular design, propelling our applications and our circular ambitions. All these three cornerstones and all what I just told you in this quick overview, we will learn in a short moment much more in detail, but we will maximize recyclability, we'll boost material safety and consistent quality, and this, as we know, is crucial for retailers and brand owners, but first and foremost also is building consumer confidence. This is what we do today, this is what we are and where we stand for today, and I'd like to hand back to Chrissy to take over for the event. Thanks from my side and on a successful event.
Thank you, Jens. Thanks so much. Well, that is actually a perfect lead over to our next speaker, Herman van Roost. As we turn to the circularity matrix that Jens just introduced. Herman, good morning. Help us to understand what the circular matrix for polystyrene holds for our value chain. Over
Good morning, Chrissy. Good morning, everyone. Hello from Brussels. It's a real great topic, circularity matrix. I suppose it creates a number of question marks, but I'm really happy to show you how this tool will help us in creating the circular economy for polystyrene. Basically, we are on a mission here to develop the circular economy of polystyrene, and actually we start always, like every material, you start from a linear situation in order to develop the circularity. We have a vision here, and in our vision, every polystyrene molecule lives multiple life cycles, and it should maintain the highest economic and societal value, because that's the definition of circular economy, actually, staying as long as possible in the economy and having at the highest possible value. The key to that is high purity recycling. And obviously we have three technologies, but for the design for recycling, we will focus on the mechanical recycling, because once you optimize that, there will be also an optimization, also benefits for the other technologies. And that is the role exactly of circular design, to anchor, not only to improve, but also to prevent fallback, to anchor the situation. And it's actually one of the greatest expressions of the value chain cooperation that we are having here at SCS. Circularity is not something that we have invented. On the contrary, we have a number of examples. As you know, we were inspired by the PET bottle recycling for developing our process, but we look around also further. Circularity is actually a material property. It's a material characteristic. And if you look at some mature circular materials, like in this case, we took the example of paper cardboard. If you look how it is done, actually it is much more than just circulating. It is actually a very well constructed sequence of open loops and closed loops. Actually, in this particular case of paper, the circularity is mainly realized at the end of after two open loops, the closed loop, and it's even a frequent closed loop with the cardboard boxes. In order to get there, you go through two mostly open loops. If somebody would require that the magazine sector would be circular on its own, it would first of all create a lot of problems for the magazine sector, but it would also prevent a lot of circular feedstock to go to the cardboard boxes. and so the circularity of the material is composed by all these, and all these applications and all these circularity models contribute to the overall circularity of the material. And that is a philosophy that we want to apply also to polystyrene. So how does a material, what determines actually the sequence, or what makes this profile of circularity of any material, by the way? First of all, the presence of multiple high-value applications. And we have seen some of these applications in paper cardboard. They have much more. But also polystyrene has a lot of high-value applications. Polystyrene has a history of 70 years of application developments, and actually there is a lot of applications. Of course, there's a couple of main applications, but there's a number of things that a lot of people don't even know that is polystyrene. But then what is really important also is for these key applications, the capability to recycle back into food contact. And well, paper cardboard doesn't have that, but they have other advantages. But in polystyrene case, well, it is perfectly capable. And why is that important? Because once you can do that, going with food contact, you have an access to all applications. Whereas if it's non-food contact, then you're limited to a number of applications. Okay, you have to be lucky that there are sufficient non-food contact applications. So the highest value, high society and economic value that we pursue is obviously by giving the maximum amount of outlets, the widest choice for a recycler to go to different applications. Another thing is, another great asset is if the applications, or if sufficient part of the applications, have no mass coloring. Because in mechanical recycling, once you color in the mass, once the pigments are mixed with the polymer, it's, let's say, over. You cannot get it out anymore. Again, if it is not colored, you have an access, the Recyclass has access to the whole range of applications, uncolored, brightly colored, gray colored, whatever so it will have a maximum value for the recycler. But if it is pigmented, colored, if it contains that, well, in the best case, it can go to bright colors if you do a very good color sorting, but most of the time it will end up in gray and black. So basically, this is the context that determines our circularity. Now, actually, there is one thing that is not relevant. That is the form, the physical form of the polystyrene applications. You know that polystyrene has developed into rigid applications, the HIPs and the GPPS, but also into foamed applications. And typically you have the XPS trays, you have the fish boxes in EPS also, and there is even also shock protection. So most of you will remember that 2 years ago, the EPS Sure project has demonstrated the capability to mechanically recycle into food contact and then to become yogurt pots. So basically, that is an important thing to understand. The criteria, food contact recyclability and absence of color, these are really the drivers and these are the criteria to segment, to create a circular segmentation, but not a form. And that is a great asset for polystyrene because it means that that circularity brings all these materials, all these molecules, all these forms back together. Now, here in this matrix, we are looking at a circular segmentation of the packaging, only packaging. And so I have applied shades of green that express, let's say, the priority or the logic or the technical feasibility, circular value, and the high potential for recycled content. So you see that there is a lot of cross-fertilization possible. As I said, fish boxes can become yogurt pots, etc. And so basically, this is a great way of understanding where can the recyclate go, from where can this application receive recycled content. So so that's a new environment actually, which is very specific for polystyrene. Now, actually, we have been focusing, and that was the star of our work, we have been focusing on the closed loop for yogurt pots. And that is really, it's important because it's one, first of all, it's a food contact application, back into food contact. It's, there is a lot of white and uncolored material there. But you see that if you look upstream and downstream, there are many possibilities. I talked already about the fish boxes, which can become yogurt pots. But downstream, the yogurt pot recyclate can become part of fridge liners. And it's an excellent example of why open loop is not destroying value. On the contrary, fridge liners require also food contact material. And also, so basically, I have here drawn a number of these lines. You can also make yogurt pots from XPS trays, and especially if they're not colored, of course. And here you see the dimension of circular design coming. So basically what we have is the closed loops are extremely important, but the open loops are very, very complementary and have the capability to fill the whole, let's say, to fill the whole scheme of polystyrene circularity. And it's all based on high purity, of course. Here we are not talking about open loop, let's say, accepting a lower quality. Now, if once we have looked at the matrix for packaging, already quite complete, but if we look at more applications than packaging, more other sectors, actually we will find another scheme, and basically what you will see always is packaging is in a very special role. Packaging in general is a universal donor, what we will say, and it is one of the aspects that we look at when we study circular design of an application. First of all, we look at recyclability, of course. Can it be recycled? Can it be sorted? Otherwise, it's over. Will it come out as a high quality recyclate and have good effectiveness and efficiency? But then also, to which applications can this be a donor? These applications. So which would be the downstream applications that could also benefit from this? And at the same time, to what extent can this application receive recycled material from other? So the receiver capability, and looking at several sectors in a very simplified way, you will always find that packaging is very interesting for all applications, and typically construction is going to be accepting, it's a universal receiver actually. Now the fact that packaging serves as a universal feedstock donor makes also that it is the top of the circular chain. It will probably have some loops in itself in the packaging, but after that it can have a perfect and longer lifetimes in other applications, and therefore it deserves a special care in the design, not only just for itself, but okay. So here we are at this more complete, more comprehensive circularity matrix. Actually, in the upper left corner, you find back the packaging that we saw before, but it is now extended with other applications. And obviously, what you see is in the shades that the closed loop, the diagonal expresses the closed loop, which is still for almost all applications a very high and logic and feasible value. But you see also that many applications can find on the horizontal line complementary destinations where they can live a short or a longer life cycle. Now, And in here we have still the colors of shades, so it gives a qualitative overview. It's already a nice value because it brings the value chain together. Most sectors have no clue what happens in other sectors with the same material. And so in bringing the value chain together, this already helps to see opportunities for each of the individual partners. So what is upstream potential? What is my downstream potential? And so another way that we use it is in a quantitative way. As you know, our industry has a big intention to become circular, to get a maximum amount of recycled PS molecules used. That is not going to happen by accident or by emotion. Okay, we intend to use this first of all to monitor how much volume is going today where, and then how to steer to a different, or where should we steer, where should we do the effort. In circular design, it helps us to say, okay, maybe this design feature will help the closed loop, but if we go a little bit further, it will help a whole horizontal line. So that will definitely give priority to that. And then, of course, to the individual actors of the value chain for recyclers, it's a great tool to understand where can we maximize the value of our recyclate, actually by where can it go. And also reverse for the users, retailers, brand owners. So this recyclate, where can it be? Where can it receive its circular feedstock from the different? So it's a great tool for our industry to where circularity brings together the entire PS family, and this way we accelerate the high purity mechanical recycled PS, just like the EU plastic strategy is supposing us to do. Thank you. Open for any question.
Thank you so much, Herman. Herman, you said that employing the circularity matrix maximizes the amount and value of our feedstock for high purity mechanical recycling and obviously the different applications. Could you give us, please, a feel for the potential by how much it would actually increase the feedstock available for recycling and for the different high-value applications?
Sure, it really depends on the application itself. But if we would look at the EPS fish boxes, typically, today a big part of the fish boxes are going to insulation. Some are going to incineration, of course. But if 80% of our would become yogurt pots, then that would add more than 100,000 tons feedstock. So that's one example, but it is even bigger for the XPS trays. XPS trays, if they would become feedstock for yogurt pots, that would add even more. And that shows also how important it is to make sure that XPS trays have access to recycling. And by the way, we are in the process at SCS to define the mechanical recycling also for XPS trays into food contact material again. And but the first condition is, of course, that it is collected. And this is one of the weaknesses in many countries still today. But we hope to be able to convince the decision makers for that in order to let it access the yellow bin or like any other package.
Excellent. As you say, SCS is working also on XPS trays back to food contact, so we will hear more about that in future events. Thank you, Herman. And that lets me move on to our third topic. So far, design guidelines have been very successfully employed for PET. And also here, SCS is working with Reci Class on design guidelines for polystyrene back to food contact recycling. To introduce this, we have here Frank Eisenträger from INEOS Styrolution. Over to you, Frank.
Yeah, good morning, everybody from Switzerland. really happy to present you and introduce you to the recycling guidelines we have discussed and established within SES. And before I do this, actually, let me recap the key recyclability features that PS has naturally and also in our applications. So the basis of all our food contact petitions is that we have a low diffusivity polymer. That is a difficult word, but basically it says that in the use or waste phase, nothing really migrates into the plastic. And then in the next application phase after recycling, nothing really migrates out of plastic. So that is one of the key features and just a gift which we have. Another gift is the broad range of recycling technologies which we can use. So mechanical recycling, depolymerization, mixed waste pyrolysis, you name it. Yeah, so a really big range. And also in the sorting centers, we heavily rely on the NIR recognition, and that is also, yeah, very nicely, very specific. So it's very precise recognition of polystyrene and the different variations of polystyrene. I mean, what we established in the meantime is that we have a closed loop also possible for food contact, so from food contact to food contact. But not only this, I mean, if you look at the applications which we have, we rarely use black pigments. So all that big issue with NIR detection of carbon black, we basically don't have it. So that is a very nice feature. We have a lot of monomaterial packagings anyway, so we don't even need to change that. If you think about the misuse, then in PET bottles, because you can easily close a bottle, that is really a topic. For a yogurt pot, not really, because basically it's open. It has no possibility to close it again, and therefore, well, the ambition to misuse it is maybe less. And then second, even try to pour a solvent into a yogurt pot made of polystyrene. I mean, the polystyrene cup will simply melt away and take itself out of the recycling loop. Last but not least, we have seen that in polystyrene, actually, we can have multiple extrusions without degradation. And this is also one important feature that allows for perfect recycling. Now, let's see for the recycling guidelines. So we developed them together with Reci Class. For those who are not aware of what Reci Class is, that is an organization coming out of the Plastics Recyclers of Europe. So that means this is the knowledge of all recyclers, and very much appreciated if you think about how to design better a certain packaging. Very easy classification we have. So a traffic light, green means full compatibility, yellow is limited compatibility with the recycling processes, and red actually is a low compatibility, which means that should be avoided. To even give finer differentiations, there are even letters from A to F, A and B, meaning everything is actually really good, and D, E, and F is then the problematic classifications. Reci Class and the Plastics Recyclers of Europe have that already existing for several applications. So first of all, of course, PET bottles, but also PET trays and others like PE, PP, HDPE. And now this is also there for PS colored containers. And we will have a look into this in slightly more detail. So let me introduce you some exemplary properties which we have discussed and covered in this guideline. What do we need to do to achieve the green classification, the full compatibility? So in the PS content, I think it's pretty clear. So we need to be as high as possible. So the ambitions are from 95 to 100%. In the color, we'll come to that in more detail. White is preferred. Then there is something you might not be aware of, the easy to empty index. That is really important for bottles. And if you think about a toothpaste tube, so then there are always remainders. Actually, we have a good situation with the yogurt pot because the opening is huge, so you can easily empty it. On the other hand, the yogurt is relatively viscous, does not always go out, so there might be some remainders when you throw it away. Then the inks, so yogurt pots are typically printed. The inks need to be food contact, of course, and also non-bleeding, non-leaching in the recycling process, and also easy to wash off, actually. Lids and labels, I will not focus on this one because there's this whole presentation which comes just afterwards, so you'll see that. Glues and adhesives to fix those lids and labels. There it is preferred that the release temperature is as low as possible, of course. So either you have a hot wash, then typically that is released, but if it could release even with a cold wash, that would be preferred. So a few other examples, and here we have an example of a partially foamed pot. So there are smaller bubbles in the plastic, which actually makes a lot of sense if you think about a linear economy. So there you, with the same stiffness, you reduce the amount of plastic material. But in a circular economy, and especially in the typical recycling process, which we have in all recycling plants, we have a flotation step. And in the flotation, you sort by density, and typically PS is sinking. Now, if you introduce some bubbles into the PS, then it's all of a sudden floating. And that means if you concentrate on the sinking fraction, you simply lose out this material. So the solution to that would be, well, go back to the rigid cups without foaming. Might even allow you to have the thickness a little bit smaller. And the benefit is, of course, it will increase our sorting efficiency and the feedstock availability for recycling. Colors. Here we focus predominantly on the in-mass colored plastics. So there we prefer white, because this has, as also Herman explained, the best recyclability and then applicability into further applications. If it needs to be colored for any marketing purpose, then a light color would be preferred, and this is why we sorted light colors to the limited compatibility. And dark colors like brown or black or even non-NIR detectable black, this is then in the low compatibility section. Benefit of having more white is clearly that we don't lose the value of the recyclate. Now the paper cups. A lot of you, all the specialists will know this under the name K3. So this is a cardboard outside of the PS cup in order to make the PS as thin as possible with ensuring the stiffness and also giving, of course, the branding possibilities. Now there's again a topic. So if the cardboard is glued to the plastic, it does not easily separate, not in the sorting center, and therefore it will come into the washing step. And then in the washing step, the cardboard will slowly dissolve. You will have the fibers everywhere. This will be not really advantageous for the wastewater treatment. So this is an issue and to be avoided. And this is actually why the glued cardboards we have pushed to low compatibility. But there is a solution to that. So there are now, and we just got the information of our SCS member Greiner about that pot which you see here in the picture. This is a self-separating cardboard. So on the slightest pressure from the top or anywhere, so maybe even before it hits the sorting center, the cardboard separates off the plastic. And this then reveals the white PS cup underneath, and actually makes it possible that the cardboard is recycled and the PS cup is recycled. So that is really exemplary for a successful design and exactly what we want to achieve. So to come back to Reci Class, they are offering two sorts of audits. And I have to mention, of course, that there are also other organizations who do audits. So this is just an example here. For the recyclability, there are there are also in France, COTREP and so on, who give guidelines for the recycled content. There are others like ISCC Plus and so on. But now here as an example, so the recyclability, you can certify your packaging and get a label A, B, C, D, and you can even print this then onto your packaging. So this is what we just discussed. And then there's of course also the audit for the recycled content. One of the possibilities that you show and audit to the brand owner, to the customers, to the consumers, that you have, say, 100% recycled content or 30 or 50 or whatsoever. Yeah. So these are totally independent classes of audits. So in a quick conclusion, the majority of our PS packaging is already well designed for sorting and recycling. So we have a lot of wide applications and a lot of monomaterial applications. Those guidelines here should or are supposed to give further guidance on how to improve and make it even better. And with the audit possibility and the certification of your packaging, you can even make it visible to the consumers with a certified label. So what are the next steps? Next steps is that we take these guidelines now and we'll discuss them with the brand owners to achieve the maximum impact, of course, and then also share these with other institutions who issue guidelines, as I mentioned earlier already. So that is then sharing of the best practices. I think for PET, this is already widely done. For PS, it's still starting, and therefore we want to push that a little bit further. And then, of course, EPS and XPS, there also a guidance is work in progress. And with that, I hope that I gave you a nice overview, and I would hand back to Reci.
Thank you, Frank. Very encouraging. You've shown the different preferred design solutions for ideal sorting efficiency and then maximum feedstock availability for recycling. Now, looking at the current design of yogurt pots in the market today across Europe, into which Reci Class classes do you think they would fall? So how do you think they would be classified?
That is actually a difficult question. If you have not done it one by one, then it's really difficult to give the average, no? But I think, as mentioned, we are already very good because we have no black and we have monomaterials, mostly, not all over, but really predominantly monomaterials in the cup. And we also have a lot of white. So I would expect that actually a lot of examples are in the green section. And well, then let's hope that we can work on the few which are in the yellow and the red. All
right. So already a good starting base and some more fine-tuning to do. Excellent. Thank you, Frank. And a practical example of what we can expect to achieve a Reci Class A classification, as mentioned by Frank, would be the monomaterial polystyrene yogurt cup that you're going to hear about from Jivan and Gauthier. So please tell us more about this monomaterial solution and what it means for our value chain. Over to you, Gauthier and Jivan.
Thank you, Reci. We are really happy to present this project, this eco-design project that is currently being finalized. So this morning, together with Gauthier, we will give you a feedback of a real proof of concept of a project that will foster the circularity of polystyrene. So our ambition, our vision, finally, is quite simple. It's a quite simple principle. We want to offer on the market a yogurt pot that is composed with the same material, three components: the body itself, the lid, and the label, transparent label here, made from the same monomaterial pot, and here we are talking about a monomaterial polystyrene pot. And this is the project we will introduce you today. So very important, this is not a project from one company working on the side. This is a partnership across the entire value chain of polystyrene packaging. So I will let Gauthier introduce the role of CTO in this project and the role of each player here. Please, Gauthier, go on and explain what is the role of CTO and who are the different participants.
Thank you very much, Jivan. Yes, indeed. Actually, CTO, in few words, we are a private company responsible for the EPR scheme for domestic packaging in France. And yes, in 2019, in a call for projects, we decided to select this very interesting project regarding the yogurt pot. Actually, that is true that the dairy product industry gave guidelines regarding eco-design for yogurt pot, and there were different industry that were really convinced and motivated to work on such a project. So we gather the whole value chain, and that therefore we decided to sponsor this project because it was a project really interesting, but also gathering all the different actors and stakeholders from the value chain, beginning with Amcor, which is a really big private company dealing with flexible film and specialists for printing and transforming, coating the flexible film. Setup, of course, that you represented, Jivan, for piece rigid sheet. Of course, we were with the brand owners Tribala Noyal, that is a French brand owners doing Vrai or Sojasun, which are quite famous brands in France, and Plastic Votna, which is a specialist for label and lead converting. And last but not least, we were working also closely with EMA-RK, which is a dairy FFS, form fill seal machine manufacturers. It's really important to have them aboard because with them we had the possibility to fine-tune the different settings on the machine, which is really important for this project. So as you see, it's a whole value chain all gathered, and therefore CTO, the EPR company, decided to sponsor this project and to be able then to, as you will see, to spread it. So that's all for this. That's all for the partnership and all the different actors.
Thank you, Gauthier. So thanks, Gauthier. Thanks a lot. So what is the initial insight? Why this project is being developed? Because of a situation, of a current situation. If we just take the example of the French market, that is quite representative, in fact, and we have precise figures thanks to CTO, here is the situation. Yearly, the polystyrene packaging market in France is around 105,000 tons yearly. And more of the half of this quantity is only packaging for yogurt pots. So thereof, these yogurt pots, around 98% are made of the three components that I showed before: the body, the label, and the lid. Normally, the body itself is traditionally made from PS. The label is a paper hot-melt label currently, and the lid is paper or aluminum and paper or mixed pack. So we have three components made from three different types of material. And this use of multiple materials can result in complexity, in sorting losses. So our challenge here with this project is to foster sorting and recycling for polystyrene in sorting centers. We want, with this project, to increase the feedstock of polystyrene to be recycled and to achieve a closed-loop circularity for full contact polystyrene. This is where the project is starting. This is the initial vision we have. Now, when it comes to more in detail, the purpose and target of our work, let's say that simply is to develop a monomaterial yogurt pot made of circular polystyrene in order first, as I said before, to increase the value for sorting centers to invest in dedicated PS lines, and also to participate doing this in circular economy for polystyrene in France and more largely in Europe as well. Doing this, we will definitely support also the French regulation. As you may know, as you all know, the French regulation will require 100% of plastic packaging to be recyclable or reusable by 2025. Our project is completely in line with this requirement, and this is also the objective of the project. So, doing this, we will achieve a real closed loop for the food contact polystyrene. Now, if we go a little into detail, what is the methodology of our approach? We want to develop polystyrene film solution. Two main aspects. First, we want to replace the current paper hot melt label with a mono polystyrene co-extruded label, and the thickness is around 75 to 80 micrometers. And number two, we will have to replace the current paper Papix lid with also a mono polystyrene lid with a thickness around 63 micrometers. By doing this, we will monitor two very important aspects. First, we will have to ensure the mechanical integrity of the pot itself, the closure, the stability, and the snappability. And important point, as Gauthier said, we will also have to be sure about the compatibility with the current thermoforming machines that are installed in the factory of the dairy producer. This is one very important aspect of the project. We don't push for important investment. We will fine-tune and adapt the current thermoforming form fill seal machine to this project. So for past several months, we ran multiple trials in the factory of the machine manufacturer, but also in the factory of the brand owner Tribala. And this is very important. This is the concept of a partnership. We can have a clear vision of the project, of the full project, with having different tests in the real condition of a dairy factory. So during these trials, we followed several points. First, we want to ensure the optimal sealing of the polystyrene lid on the body itself and the very good cutting. And where we are now, we are really happy and convinced that this optimal sealing is possible with a PS monomaterial lid on a polystyrene body. This is possible, and this is already adjusted. The second point, for sure, once the lid is sealed, we will have to be able to reopen it for the consumer. And also, we have to test the peelability of the lid, the correct opening of the polystyrene lid. And this is working as well. Doing all this, as I said, we have to ensure the compatibility with form fill seal current machines. As I said just before, this is to use the current existing machines. And during the whole process, for sure, we will monitor carefully the food safety compliance. For sure, this PS is not a new material for dairy application, but just because we are developing a new principle, a new approach, we have to monitor at each stage of the project the safety and the food contact. And this is also a normal part of the process that is also monitored during the whole process. So these are currently the point of success that we achieved. We are sure that these points are possible with this project. Now, as I just said, so the yogurt pot is existing. As I can show you here, you have the full monomaterial yogurt pot that has been made inside the factory. Well, here you have an example of empty pot, but we also run trials with a dairy product filling, and it's working well. The snappability is good, perfect, and the opening as well is good. So this is technically achieved, and this has been done on current FFS lines. Now, for the coming months, we have to finalize some specific points. First, we will run industrial testing. I mean that it will be a test on the long run with a full filling of the product, and we will monitor this at a larger scale. This is the first important point. Second, we will also ensure that this product, this kind of cup, is perfectly fitting well in sorting centers. For sure, we are doing this to make life simple for polystyrene in sorting centers. So this is one point we will perfectly monitor and see if there is any adjustment. And last but not least, if we are doing this as a monomaterial, this is not only to use virgin polystyrene, but this is also to include and to foster RPS. So we will definitely work with some partners in the recycling technology to be also convinced that this kind of pot is also fitting well for recycling technology, and we will definitely also include part of RPS in the monomaterial project, and we will go up to 30 to 50% of RPS in the monomaterial in each component. And this is the last challenge we have here. I will give the word now to Gauthier. He will give you the conclusion of our presentation and the opening as well.
Thank you very much, Jivan. Yeah, what is ahead of us still? We still have to run some tests and trials regarding the sorting efficiency. Of course, one of the objectives of this project was to make some a packaging that is much more homogeneous, and then make the sorting much easier in the sorting center. We had already some trials done, but we have to make some relative comparison, I would say, with standard pot, with pot with PS lead or PS label already, and see if the performance of this new solution is really giving the advantage that we were expecting. Of course, you know also that we have a simplification in France of the sorting instruction regarding domestic packaging, that and such a yogurt pot will also give the benefit of giving more PS for in the sorting center and more PS for trials in the recycling operation, and the PS feedstock will be in higher quality also, so it will make the recycling industry much easier to really muscle, I would say. And then of course that is something which can be done now in a short term, and that is really important because we have to bring solution quickly, and that was one of the objectives of keeping the machine and having such really few settings to make on FFS machine, and of course regarding the timeline, then that gives us the opportunity to have such yogurt pot on the shelves by the mid of 2022, and that's a really good for the PS image, I would say, because we have to bring now proof to the market, to the consumer, that the PS packaging are we can really have solution regarding the recyclability and the real recycling. So that's a project that we are really proud of by CTO. We had a really good team representing all the value chain, and that's really a good example of how the industry can really gather itself and brings us a really good solution that is feasible for everybody rapidly, and that respond to the different challenges we're facing. Thank you very much.
Thank you both. That is actually quite exciting news to hear that the Monomaterial yogurt cup is expected to be on the supermarket shelves already next year, and that this is a solution that can be quite quickly implemented. Cannot wait to have it in my hands. Gauthier, I assume that there are a lot of dairy producers next to the consortium brand owner Trebala, looking forward to improve their sustainability footprint with this monomaterial solution. How can we ensure that also other market players benefit from this new advancement, and that this solution can actually have this fast amplification effect that you just talked about?
Thank you, Chrissy. Yeah, indeed. The idea of CTO and being, I would say, in the middle of this ecosystem is really to have the possibility then to share such initiative to all different clients. By CTO, we have most of the dairy brand owners in France, and much of them are actually European brands. And we give the possibility, and that's the contract, I would say, when you respond to such a for project, we are sponsoring the project, but then the idea is to share also the results, the challenge, the difficulties that you faced for the different brand owners, then to I would say win time and gain time, and have the possibility also to implement such a solution by them for their portfolio, for their products. So of course, Trebala will be a bit ahead of time in comparison to the other, but we will share all the different results we have, and we will share the solution for everybody.
Very encouraging, very great to hear. Jivan, I'm already monitoring the chat here, and I see a couple of questions going into that direction. We have heard in past events the rather passionate testimonial from converters such as Coexpan, Greiner, Intraplast, and not last yourselves, that mechanically recycled polystyrene performs as a drop-in solution in the existing form-fill seal equipment. Now, can we expect that recycled polystyrene will also perform as a drop-in solution in the lids and labels as part of this project?
Definitely. This is the sense, this is the purpose of this project, is to have a monomaterial pot to include recycled polystyrene in each component, the lid, the label, and the cup itself. So for sure, if and when the chemical and mechanical recycling technology exists and is food contact compliant, it will definitely go along with this project inside the body, inside the cup, and inside the lid. This is the reason why we are developing this project. A monomaterial cup made from virgin polystyrene doesn't make much sense. So the target is to put high level of recycled PS in each component, definitely, Chrissy. And this is what we are working on, to improve the feedstock for these technologies and to put it inside the cup itself.
Excellent. Excellent, great to hear. And with that, a big thank you to the two of you, and I would like to bring now all of our panelists on the screen for some further questions. And while our speakers turn on their cameras, this is over to our audience. Please do continue to submit your questions. We will make some time to cover them, and yeah, let's have a welcome back to everyone. Now, polystyrene, that it has completed quite a number of milestones designed for recycling, is at the core of what SCS and its partners are focusing on. A couple of questions to you. For which styrenic applications would you see the highest value for design of recycling? Where should the value chain start first?
If I may take this question, Chrissy, as shown in the circularity matrix, packaging is the highest priority. It is the feedstock that is really at the top of the circular life cycles. And it will first go within packaging, but then it has a great possibility to go anywhere else. And so it deserves really to be taken care of, dedicated care by our industry. So that's for me the biggest. It doesn't mean that it is today not good. Also, on the contrary, it's already very well feasible as we shown. But maximizing that is going to generate the biggest benefit.
Thank you. I see a lot of nodding to that.
Yeah, I can quickly jump in. I think really the yogurt pot. No, the yogurt pot is the biggest application, and that needs to be our focus now. So this is where we are looking to. That's number one.
And there are then also some markets that have a preference for colored yogurt pots. Specifically, I guess in France, yeah, where we see red, green, and even brown. So that would then be also a priority for design of recycling.
Yeah, of course, guidelines for such application and PS guidelines for eco-design are really important to bring on the market. And as soon as we got the information regarding the recycling operation, then the market can adapt. I mean, it could take some time, and guideline methodology are really dedicated for such a real big turn for the market and for brand owners to really adapt their solution regarding the recycling operation. And it will be the case in France, I'm pretty sure.
Excellent.
I
Excellent.
also experienced in the working group discussions that there was a high willingness to improve. Actually, this is why we are working on those guidelines, no? Because we want to be clear what is necessary for recycling and then act accordingly. So I've seen that willingness, and that makes me very positive.
Maybe a few words, Chrissy, regarding COTREP, which is actually the mirror of Reci Class in France, and the same as Reci Class did for guidelines for eco-design, we will do the same for COTREP also in France.
Wonderful, wonderful, great. And I'm seeing here already questions popping in on the competitiveness and cost. So how does implementing the design for recycling with the PS Monomaterial solution and Reci Class guidelines affect the competitiveness of such eco-designed packaging from a cost and sustainability perspective?
If I may, when you evolve from a linear context into a circular performance, then in this transition, there is always a little bit higher costs. It's totally normal. It's a sort of birth pain. But that is only the start of a new optimization. And once you go sufficiently far in this new optimization, there is a lot of cost benefits by the simplicity that is often brought by the design for recycling.
May I?
Yeah. Go ahead, Jivan, sorry.
Sorry. No, just about the cost, the cost issue, and this is a very valid point, in fact. And for the project of Monomaterial yogurt pot, this is also one important point we kept in mind. Definitely, for example, taking the importance of working on the same FFS machines that were already installed in the factory was a very important point to avoid any new big investment in new machines or new big changes. So definitely, when it comes to cost, the eco-design has also to be well managed in front of the reality of cost. And by doing this on the current machines, we also definitely kept this in mind.
Maybe a few words about the French situation. By CTO, we have our fee, our tariff, that is depending on the different plastics, depending on the robustness, I would say, of the recycling operation, the recycling industry. But also we have the possibility to put some eco-modulation on the fees. And that's also a tool that we can use also for this transition and this period where the costs might be a bit higher than the standard solution. And if the guidelines for eco-design and if the recycling actors told us that's the way we should go. CTO has the different tools to bring the market and bring the brand owners to the right solution, and having this transitional period that might be harsh for some of them.
Very glad that you touched upon that. This was also already a question in the chat. All right, great.
Let me maybe add, I don't think it's only a question of cost. So I think also what is added is, if you can put that label onto your packaging, then this is a marketing device. So that is maybe much more important than just cost of the packaging. I don't want to say that cost is not important, by no means, but there will be more factors coming in, for sure.
And this was also my point, Frank, you took it in a way. However, I think since I'm in the way on the European parquet in Brussels and know what it's all about, first of all, design for recycling now is really everywhere, and it's striking how it's accelerating. So it's good that we are proactively and voluntarily working on that. And also looking at our today's audience here, I'm talking to a lot of retailers and brand owners, and the fact that maybe they are not visual in the SCS membership does by far not mean they are not there, and they are surely now listening what it means with regards to marketing. And we all agree in our discussion that we only today can assume on this tremendous potential, and not only on the cost, but also in complexity, in processes, and standardization, and again in messaging and marketing to the end user. What are we doing here? So this is really striking, and for this reason I think a strong message to those I know, and maybe those outside I don't know, but for retailers and brand owners and finally the end user, what we do here is really great stuff.
Excellent, thank you so much. And there are a lot of questions that are popping in. So let's turn to our audience. First question: will the Reci Class guidelines become compulsory? What are the expectations? Frank, would you like to take this one?
Yeah. So I think actually they are not intended to be compulsory. So for me, they are voluntary initiative to really improve the packaging. And I've seen, so we said, the big willingness of the total, the full supply chain to do so. So maybe the recycling content will be compulsory. The design, I don't think so. But as Gauthier said, maybe that will be subject to the modulation of the license fee or so. So there could be even a cost point involved, but I don't see an obligation right now.
Okay.
I don't think that we need, what we feel from the market, from brand owners, from retailers, is not a sort of resistance. I don't think that we will need an obligation. On the contrary, we will be pushed by our downstream users to let them help. They are asking for, tell us what to do and make it a standard, and then they will be happy to apply. So
yeah, I think there's an indirect impact to elaborate what Hermann said also. I think Reci Class, and it was mentioned, Reci Class, part of the European Recyclers community and PRE, I think being in compliance and boosting our Reci Class compliance is a strong message to the value chain. We said that, but also to the recyclers first of all, because in this area we talk today, the mechanical recycling, high purified, we need, of course, the commitment of the recycling community. We need all, and also the recyclers themselves, they need somewhat certainty, consistency. They want to invest, and they want, of course, to invest in something with future potential. And I think this we indicate to the recyclers, also our value chain, giving this consistency. I mentioned the processes, the standardization, the competitiveness is a strong signal also to the recyclers, which we need somewhat inevitably to dig and raise the feedstock potential and really boost the availability of circular polystyrene.
Thank you. And how easy is this monomaterial solution for yogurt pots transferable to other dairy applications?
Chrissy, maybe I can take this one for sure. So, my opinion, our project is a proof of the high versatility, adaptivity of the polystyrene. In different applications, we see that we can work in a very large range of thickness and with a very positive impact on different mechanical constraints. So our project for sure is focusing on yogurt pot because this is the value chain we are in, but definitely it shows that the results, technical results, show that this project is will also benefit for other polystyrene application or other non-yet polystyrene application. I'm quite confident that the results we are having could be transferred to other type of packagings for monomaterial application, definitely.
Excellent. And I see in the chat there's also a question of applications with a longer shelf life, baby products, whether that would be also applicable. You're now focusing on the yogurt cups, but the transfer to other applications, be it dairy or the foil for longer shelf applications, is then the next step. Excellent.
If you always talk about yogurt cups, so for me that is symbolic for most of the dairy packaging. So be it a creamy cheese pot or a yogurt drink, they all have label, and this new technology will make it possible to have that label out of PS. So I think there, for sure that will work. Yeah. So we always say yogurt cup, but we mean basically the dairy packagings.
Wonderful, wonderful.
Actually, if I may, in this kind of project of which the results will be on top published, it is very logic, or what we can expect is that others will get inspiration, because what these people are actually now doing, these companies, is giving a little demonstration of the versatility of polystyrene, which could not find its place in a simply linear environment or a cost-driven environment, but which find definitely their place in a circular environment. And so I'm sure that many technicians were not aware of the possibilities here, and they will find inspiration from it. That's my expectation.
Wonderful. And a question that also falls into yogurt cup food contact is, how far are you with your petition to EFSA? Jens, if you could take that question. For EFSA, we have applied.
I also handed this to Frank. He's maybe as close as I am. But Frank, step in or correct me if I say something too premature. But basically, I think premature is we have passed this. We have filed this first EFSA application, you know that, in March. So 6 months normally is the waiting time, which can be extended for good reason by another 6 months. A good reason so far we have not received. It has to be admitted that the European environment, EFSA, also inclusive here, from all the corona and all other impact, is also a bit, I would not say slower. This is too negative, but surely heavily working. The good news is we have not received any objection or critical question or pushback on the analysis data we did together with Fraunhofer. I would say we could and should expect it any time in a way. And as we are nervous, we use the time to also in process of launching a second application, Frank, you know that, and handle that in your area. So we are very busy. The good news, as many knew and know, we are not waiting, and we don't have to wait for the EFSA. We are heavily working also on ABA solutions in order to work with circular polystyrene and recycled content. Again, Frank and the team and Hermann is involved here. We are very close and pushing this forward. So it's not that we are absolutely victim of circumstance, this EFSA. Having said that, and maybe on the other question on the shelf life, I think also what prevails for the virgin polystyrene is, of course, the absolute domain, and for good reason, of polystyrene. And give us some time and not to lower expectations here, but we are fully busy in getting the virgin polymer to the circular polymer, which obviously has then the same benefits with regards to cost availability like our virgin. So we expect that the shelf life discussion in a way where we are in a domain, if we transfer it one by one and the, let's say, property, it should be already good. But let's take it maybe in a way that circularity and polystyrene is a young dimension that we, of course, look at those perspectives. But again, first you will transfer virgin to recycled, which already will offer the same benefits. Yeah. Just to conclude on the earlier question.
Excellent, thank you so much. And here I have a question to Ceteo. Where do you see the synergies between the work of the Monomaterial polystyrene project and the PS25 initiative in France?
Thank you, Chrissy. Yeah, in fact, indeed, maybe some of you know that we have an initiative by CTO that gathering all the, many of the brand owners for a dairy product in France that is called PS25. The idea is really to mutualize all the knowledge and find and I would say aim to the right solution for recycling of our PS application for domestic packaging, not only for yogurt cup, but for all the different solution for trays and so on that we are using PS. Of course, Tribala, which is one of the project leader for the yogurt pot, is part of the PS25. So all the different knowledge and all the different information are shared, and they're perfectly in line with what we're doing and perfectly following what we're doing but in the project, and they have all the information quite, more or less directly. Yeah, but of course, everything is linked. We're trying to mutualize the knowledge, we're trying to bring everything together, and the idea is to find a good solution together and bringing to the market the more quickly we can.
Wonderful, thank you. And I see a lot of, there are quite a number of questions going into the difference between mechanically recycled polystyrene and recycled polystyrene from depolymerization. Do they behave differently from virgin PS in the PS monomaterial solution? And then also, would one of the other, would chemical recycling tolerate more impurities stemming from waste? Let me put the first one over to Jivan. Do they behave differently in the monomaterial solution?
So this is the work we are currently working on. As you all know, the main difference between mechanical and chemical RPS is the fact that with chemical recycling, we are going back to the monomer of styrene. And so naturally, let's say, the purity, the quality is definitely the same because we are going back to monomer and then repolymerization. So naturally, this is food compliant and the quality is the same. In mechanical application, in mechanical recycling, we have to pay more attention to the purity of the feedstock and also to the quality of the process. But definitely, as soon as these two processes are food contact approved, we can use both. So the challenge is to use all the technologies that are sure for food contact and that are available at a good cost. Now, on the market already, we can find a yogurt pot with the body made from 30 to 50% of recycled polystyrene with the mass balance approach. So chemical recycling. This is already existing and available in the supermarkets. Now, definitely, the monomaterial yogurt pot will have to integrate these technologies, either chemical, either mechanical. And this is where we are definitely working on with number one constraint, the food contact validation.
Excellent, and we already heard about that, that one where we stand from Jens. Wonderful. Next one, how will the EU plastics tax be linked to the Reci Class guidelines? Do you expect exemption?
We don't EU maybe is always a buzzword, but Gauthier, please add on from your view, because I think in France you are quite advanced also on incentivizing recyclability, and to the extent also, of course, non-incentivizing non-recyclable materials. In general, the question, short answer would be, there's no direct impact of the plastics tax and Reci Class and our ambition. But in order to be complete in replying to that, I would say the plastics tax is all about non-recyclable packaging or benefiting recyclable packaging, and this is exactly in the core, in the epicenter where we are with our activities, and therefore being then compliant to the plastic tax requirements and with our recycled materials and packaging, we have no burden, we have no tax payments. So I would not call it an exempt, we just don't fall under it while we have presented our recyclable packaging, and therefore this is good news also for the member states, that this of course will generate what they need, because so far the plastics tax is just, don't get this wrong what I say, also contribution in cash to the European community. So it's very important that this plastics tax comes to its DNA and means that all plastics packaging is recyclable, and therefore the need for taxation is not there. Yeah. And over to you, Gauthier, maybe from France, how it's impacting also France, or if you're advanced already.
Thank you, Jens. Yeah, actually, the different member states decided to apply this plastic tax differently, and it's difficult to see exactly how it's applied in Europe, all over Europe. But in France, I would say relying on the eco-modulation on the fees, and we have different modulation under our tariffs, and especially one for integrating of recycled plastic, so recycled polystyrene, recycled polyethylene, recycled polypropylene, and we have this prime that is given to the industry, putting recycled plastic, post-consumer recycled plastic in their packaging. So that's the way we are doing things in France. There are different ways of doing this, but of course, I'm pretty sure that all the different guidelines, that is Reci Class at European level, COTREP at the national level, and all the different modulation will put more or less in place the market drivers for them to really adapt their design and to really push for the recycling of the domestic packaging.
Thank you for that. Great. And now a question, how will the Reci Class guidelines affect the environmental footprint of polystyrene and the CO2 emissions? Jens, maybe coming back to what we have, what the LCA analysis has provided as results, and which impact our design or recycling would have on the environmental footprint.
Thanks, Chris. It seems I'm having now a good run in questions here, but that's all good, and I think it's a good question also, as all the others. Again, the recycled and Reci Class guidelines, recycled content, recyclability have of course an impact. And if you look, where are we today? And there I like to recap again what I did in the beginning on our June event. I mean, we have to admit that we, with our three technologies, be it the physical technologies and or the chemical recycling, depolymerization, are already at highest levels. And if you look what we save already compared to the virgin production and incineration, with 75% to up to 80%, I mean, we scratched already a bit on carbon neutrality in a way, because this is still not including all scaling effects which we are expecting in the coming months, in the coming years. So therefore, we come from a high level, so it will be at least fully neutral if we would not do anything. But since we work tremendously on design for recycling, we should expect it will be further beneficial. And as I mentioned, standardization and recyclability and the processes which get improved, surely, together with the reduced complexity, will have a positive impact. Don't ask me for a percentage, Chrissy, but I would say again, carbon neutrality is not that far away, and therefore also we talked already about zero emissions and those things. I think we have an excellent starting point, and we are scaling further.
Excellent, thank you. And just looking at the time, there were a number of questions with regards to which kind of sorting technologies are being applied. That is obviously NIR, near infrared sorting, that really sorts out the different polystyrene forms up to even the resin level. And I invite you for that also to take a look at the past replay of the June event, where Herman van Roost really went into detail, also talking about the different sorting steps for the different recycling technologies. So I'm taking over one more question here to the entire panel. How would the implementation of the design for recycling that we heard about today accelerate the PS circularity and its contribution to the EU recycling targets? What is your expectation? How much further will that bring us? Who wants to kick this one off? Jens, would you like to make a quick start?
Yeah. As I said, I'm having a run here now with question, but again, to reward the question first, great question. And this is basically also what it's about. Yeah, if you look at where we are today, if you see what we do now, and as I said, design for recycling is absolutely a status of discussion also as a policy environment. But taking both the policy environment, our converters, recyclers, sorters, investors in a way, as we mentioned, also to have really a planning horizon here with our activities. This is all great, and we have it, and for sure this effectiveness of our measures will also boost the circularity. And I would say the role of PS, but I like to include also, as Herman said, also is always PS, EPS, XPS, and also in the future horizon, well underway, ABS and SAN. This all will, with our ambitions and activities, raise consumer confidence, as I said, not only a key requirement of the value chain, but first and foremost of retailers and brand owners, and will surely boost our circular applications because they will like what they hear today, and they will adapt, and they will further support and contribute to our circularity ambitions.
I think a design for recycling will contribute that we have simply more quantities available. I mean, this is what we are looking for. Now we are looking for feedstock, and if we have some losses in polystyrene or in white polystyrene, then this is a pity. And there, the design for recycling is not, it's not just the icing of the cake, but it is crucial. So I think it will enable us to have more quantity, and also quality.
Yes, definitely. I can testify that the project of the monomaterial yogurt pot will definitely accelerate the circularity of polystyrene. We will help the simplification of sorting, and we will increase the feedstock of post-consumer polystyrene to be recycled. We will improve the quantity, and we will improve the quality of this feedstock by these projects. So definitely, I'm convinced it will accelerate the circularity of polystyrene quite simply.
Excellent.
I have also a great expectation for the indirect effect. On top of all the direct effects that were mentioned, but the indirect effect of forcing closer cooperation and more intense cooperation between the value chain and better understanding the effects at another point of the value chain is going to bring a lot of value, like it did, by the way, with other materials. And it is really the driver of circularity.
Excellent. So what we see here is a sector that is ready to embrace all the opportunities that are out there and maximize, so that we are actually meeting, well contributing and meeting the targets of 2025 that are posted there. And with that, thank you so much. Great statements to close the Q&A here for today. Before we depart, please allow a couple of announcements. First of all, there have been already a number of people that have reached out regarding the replay. Yes, we will make that available. Allow a couple of days, please, and we will share this one on our website, but you who have registered for the call will receive that automatically. You will receive the link in your email. Likewise, also invitations for future events. Then coming back to what Frank has said in his presentation, we are planning a Reci Class brand owner roundtable in the first half of next year. And so you will be hearing more about that. And not last but not least, take a look at our new website. We've made a lot of more information and resources available for you. So we'd really love you to take a look at that one. And a great way to keep updated with this and other news that we are sharing is also to be subscribed to our newsletter via the SES website. And with that, this leaves me to say a big thank you to our attendees today, to all the wonderful people and organizations across the value chain that very actively work with us. A big thank you to you, our fabulous speakers, and to our co-host Packaging Europe, Vicky, and of course Kane, who just made the internet and the technology work magic here for us. Thank you so much. Goodbye and stay safe.